Greetings to panel of undergraduate with Project 2, Dr. Wahid and Dr. Diana. My name is Siti Fatin Norain binti Muhammad Saab, and my final year project is supervised by Professor Madya SRG as Dr. Nur Hazrina binti Idris. Today I would like to present my final year project, which the title is Sea Surface Temperature Rise for Monitoring the Climate Change Pattern in Kuala Terengganu Coastal Sea. This slide contains introduction, aim and objective, scope of study, methodology, result and discussion, and conclusion. As for the introductions, ocean could influence the weather from local scale to global scale, and while any climate changes could alter the properties of the oceans. Sea surface temperature, also known as SST, is one of the parameters in climate change, which is very good indicator in climate system for monitoring the pattern with remote sensing technology. It is found that global temperature rise and warming oceans are some of the evidence of rapid climate changes that is compelling. According to Government of Malaysia, Malaysia has recorded the SST value in January between the range of 26 until 28 Celsius. Meanwhile, in July, 28 to 29 Celsius. The South China Sea SCS, according to KADI 2004, has recorded the highest temperature at 34.8 Celsius and the lowest would be 25.9 Celsius. Also, according to you, in 2019, the rising trend of South China Sea between the year of 1988 to 2017 is 0.12 Celsius per year. This means that ocean system occurs more frequently for warming of less than 2 Celsius, while for the land it occurs more often for warming greater than 2 Celsius, making the oceans easily tipped by the changes. The increasing of the temperature of oceans is due to the rising of sea surface level, which can lead to the extreme event such as flooding and drought. The aim and objective for this research is to estimate the changes of SST on climate changes by using the thermal satellite data in Kuala Terengganu Coastal Sea. As for the objectives, it is to derive the SST from thermal sensor of satellite data. Second, to estimate the changes of SST over 5 years period in Kuala Terengganu. And the third will be to validate the SST using the in situ data. The scope study for this research is Kuala Terengganu in Terengganu, which has the beach length about 17 kilometers. In this research, it primarily used satellite data of Landsat 8, Operational Land Imager OLI, and Thermal Infrared Sensor TIRS. The remote sensing derivation algorithm used for extracting the SST value is split window algorithm SWA. It is there to analyze the correlations of SST derived with the field data measurement. This is the methodology for this research. It consists of 5 phases, which begins with data collection, data pre-processing, data processing, data analysis, and data output. In pre-processing, subset and clouding is done, followed by radiometric correction, such as conversion of digital number TN to radians. Both pre-processing is done by using the ArcGIS software. Next, the processing is continued by conversions of radian to brightness temperature in Kelvin. The temperature in Kelvin is therefore converted by Celsius. In order to extract the SST value, split window algorithm SWA is used using the equation below. To use the equation, the brightness temperature of band 10 and brightness temperature of band 11 is required. Therefore, after the processing, time series and mean of SST graph is obtained along with the correlation of SST derived with field data measurement and intercomparison with MODIS level 3 product. At the end, SST distribution map between 2016 to 2020 is also obtained. This is the result and discussions for this research. In the table, it shows the SST derived from 2016 to 2022. The total scenes that undergo the pre-processing and processing phase is 30 images. There are particular years that shown a non-value data SST retrieved due to unavailability of the satellite data. This is because of the setting for the cloud coverage at 40%. Therefore, not every month for the 5 years contain the SSTs derived due to unavailability of the satellite data. Based on the graph, it shows the time series of SST from 2016 to 2020. It shows a series of trends with an increase and decrease through time. Starting 2016, the SST has increased and dropped at 2017. Then it started to increase again but dropped until the earlier of the year of 2018. It shows that the increasing of the trend which later dropped before the upcoming of 2019. Meanwhile, in 2019, it shows not much of increasing and decreasing of SST happened but dropped at the middle of the year before it started to decrease again. In 2020, the SST shows the irregular trend with increase and decrease at the middle of the year and continue to drop at the end of the year. The second graph shows the mean SST for 5 years period. It is to remind that this mean does not represent all the monthly SST due to unavailability of the satellite data. Therefore, 2016 shows the mean SST at 30.61 and dropped until 27.06 in 2017. In 2017 to 2018, it increased at 30.10 and decreased at 2019 at 29.88. Then it shows a little decrease in 2020 at 29.85. Next is correlation between SST derived and field data measurement. The field data measurement shows insufficient amount, which is only 4 points available. This is because the field data measurement needs to be done by field work to obtain more field data measurement. But the correlation shows a positive correlation at 0.6074 and the correlation coefficient R is 0.7794. Due to insufficient field measurement data, the RMSE shows a higher value, which is 1.53. Next is intercomparison of SST derived and monthly mean MODIS product. Based on the graph, it shows a positive linear coefficient at 0.1765. The correlation coefficient for R is 0.4206. Next is SST distribution map. For some data, it may shows irrelevant of SST variations. This is because the TIRS happen to have a serious tree light problem, which is somehow band 11 is 2 times higher than band 10. Stripping and bending and SCA overlap are also some of the main problem which appears in the result of distributions map of SST. Normally for OLI and TIRS, Normally for OLI and TIRS imagery, a normal radiometric processing can remove the majority of the bending and stripping. However, the stripping and bending remained prominent, and the variance between the two sides of the strip were not insignificant. This is the distribution SST in 2016. As mentioned previously, May, June and September shows a single variations of color for SST due to the stray light problem. It shows the value of SST at the highest range is 31 Celsius to 32 Celsius. The SST started to increase from May until September, which September having the highest value of SST at 32.89 Celsius. Meanwhile, the lowest value in this year is to be in January at 27.14 Celsius. Next is distribution SST in 2017. Based on the figure, the white color represent cloud and the black represent land. Some SCA overlap are mainly seen in the result in the year of 2017. With that, it gives the highest value at 31.21 Celsius in June, and the lowest is 21.11 Celsius in February. In 2018, the variations of SST shows a single color for the month of April and September, and also appears for other effects such as stripping effect and SCA overlap. The lowest value of SST is 28.40 Celsius in February. The SST value started to increase in May at 31.363 Celsius, which shows the highest value of SST in 2018. The value started to decrease in September and October, which both value is 30.50 Celsius and 30.34 Celsius, but still appears to be in the higher range of SST. Next is the distributions SST in 2019. The variation of SST in 2019 shows the range between 29 Celsius to 30 Celsius and 30 Celsius to 31 Celsius. The highest value of SST in the particular year is 30.76 Celsius, which is in May, and the value started to drop during the following months. With that, the lowest value of SST is 28.08 Celsius, which appears to be on July. This is the distribution SST in 2020. Based on the distribution of SST in 2020, the month of January and March were not presented due to unavailability of the data. Therefore, 2020 start with the lower value of SST in February at 28.04 Celsius. Starting in the May, the value increased but dropped in July at 29.36 Celsius. The highest value of SST within those 10 months is 31.52 Celsius, which is on October, and the lowest value recorded is 27.79 Celsius, which is in December. As for the conclusion, this research was conducted to monitor the climate change using the sea surface temperature parameter. The split window algorithm, known as SWA, is used to retrieve the SST from the satellite-derived variance. The changes of SST in Kuala Terengganu were determined based on the UMT station point at the coordinate 5.44 to 85 degree noting and 103 and 103.1606 degrees easting. Based on the result, the time series of SST were examined starting the year of 2016 until 2020. Terra Modis Level 3 were used to compare the accuracy between SST derived and the data product. the correlation coefficient R between SST derived and field data measurement is obtained at 0.7794 and the RMSE is 1.53. The coefficient value of intercomparisons of MODIS and SST derived shows that the R value is 0.426. It is also found that the pattern of SST variations for 5 years of these studies shown that the value of SST is higher starting the month of May or June and started to drop in November or December. Based on the SST derived tabulated, it is found that September 2016 has the higher value of SST, which is 32.69 Celsius, and the lowest value is on February 2017, which is 21.11 Celsius. That's all from me. Thank you.